Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at similar triangles. So in a previous lesson, we found out that if two shapes are similar, then pairs of corresponding angles are equal and pairs of corresponding sides are in proportion. We also found out that for quadrilaterals, it was possible to have one but not the other. It was possible that two quadrilaterals have all their angles equal but sides not in proportion. What makes triangles a little simpler is that that doesn't work for triangles. So what that means is for triangles, you don't need to find if they have both conditions. You don't need to check if all angles are equal and all sides are in proportion, because if one of those statements is true, the other will be true. So for similar triangles, we don't need to check every angle is equal and every side is in proportion. Instead, we can use one of these four tests. If any of these four tests is satisfied, if any of them works, then the triangles will be similar. So S here in all of these means a side in proportion. A means a pair of equal angles, and R and H means something different. H means hypotenuse and R means a right angle. So for the SSS test, we're saying that if two triangles have all their sides in proportion, then they are similar. I don't even need to check whether the angles are equal. So these two triangles here have their sides in proportion because 12 over 8 is 1.5, 9 over 6 is 1.5. Remember, sides in proportion basically means scale factor is consistent. The scale factor between shorter sides is 1.5, scale factor between the longest side of each triangle is 1.5. So these have all three sides in proportion and therefore similar. So we can also use the SAS test. That is where you have two pairs of sides in proportion and the angle between. It must be the angle between. So again, we have two pairs of sides in proportion. Scale factor is consistent, 1.5, 1.5, and here we've marked that the angle between them is equal. It again must be the angle between the two sides in proportion. If I had marked this angle here and this angle here instead, we can't use the SAS test. It must be the angle in between the two sides in proportion. So this test here is probably the most straightforward. It is AAA. If two triangles have three pairs of equal angles, then they are similar. We know their sides will be in proportion without checking. So for these two triangles here, they have a pair of vertically opposite angles, and because of these parallel lines, alternate angles must be equal. So these two angles will be equal, these two angles will be equal. So note for AAA, you actually only need two pairs of equal angles, because if you have two pairs of equal angles, then the third pair must also be equal, because angles in a triangle always add to 180. All right, the last test is RHS. So that's where both of them have a right angle. That's what the R stands for. H means hypotenuse, S means another side. So they have to have a right angle, and their hypotenuses and another pair of sides must be in the same proportion. So here we have two pairs of sides in proportion, but not the angle between. Turns out for right-angled triangles, because of Pythagoras, we can get around this a little bit. So hypotenuse scale factor is 1.5. The scale factor of these two sides is 1.5, and they have a right angle, so they satisfy the RHS test. I don't need to go and check other pairs of angles. I know that they'll be equal. All right, let's look at now solving a problem involving similar triangles. So let's try this question here. A tree makes a shadow of 12 meters. At the same time of day, a person who's 1.8 meters tall makes a shadow of 2 meters. Calculate the height of the tree. So if you're not given a diagram, start by drawing one. So this will be our tree here. It makes a shadow of 12 meters. So the person who's 1.8 meters tall, they make a shadow of 2 meters. So we know that this involves similar triangles, so we're going to have to end up turning these into triangles. So now let's look if there are reasons we can believe that these two are similar. Well, you can assume that a tree is perpendicular to the ground, because when we're talking about the height of a tree, we're really talking about its perpendicular height, and that the person is perpendicular to the ground. So they have one pair of equal angles. Now, because we're talking about shadows at the same time of day, the angle the sun makes with the ground will be the same in both cases, since it's the same time of day. Now remember that if you have two triangles that have two pairs of equal angles, the third pair of angles must also be equal, because the angles add to 180. So these two triangles are similar by the AAA test. They had two pairs of equal angles, means they'll have three pairs of equal angles. So that makes our job much simpler. We can simply calculate the scale factor. So the scale factor here is going to be this side divided by this side. The shadows, 12 divided by 2, which is 6 meters. So we're now looking to find this side here, which I'll call X. It's a side in the larger shape, so we multiply the side in the smaller shape by the scale factor. Whenever you're finding a side in the larger shape, you always multiply by the scale factor. So X here will be 1.8 times by 6, which gives us 10.8. The logic here is actually really simple. If it's the same time of day and the shadow of the tree is 6 times as large as the shadow of the person, we can assume that the tree is 6 times taller than the person. And that's because of the similar triangles, because at the same time of day, the sun makes the same angle with the ground. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.